Alright, and finally we come to prisms. So we've dealt with a rectangular prism. That is a prism with a rectangle base. Now we're going to deal with our other types of prisms. So they all are defined by their base as a triangular prism. It has a triangle base that's stretched by the height of that prism. So we see that height, it can be standing on its base, or it can be sitting on its side, but either way, the height of the prism, it's the distance in between the two bases. We have a triangle base on the bottom, a triangle base on the top. The distance between those is the height. That capital B, just like in a pyramid, stands for the area of the base. And this lowercase p stands for the same thing as before. Again, it's the perimeter of the base. So we can have any shape, and then it's stretched into existence into 3 dimensions. We have this 2-dimensional face, and it's stretched by that height, however far we want to create this prism. So we are looking for the surface area of a triangular prism here. So that's 2b plus HP. Again, I think I might have flipped these around, but really I'm just thinking about that as the top and the bottom, those two bases. And HP is the lateral area going around the outside of that shape. So this capital B stands for the area of that base. That's a triangle, so I'm thinking about 1/2 base times height. I don't actually have the base of that triangle. If I think about just that triangle there, my right angle is here. So I have one of the sides that I need. I would call that the base, really. And I'm missing this side. I have that side, which is across from the right angle, so that's the hypotenuse in that right triangle. So I'm going to call this A. I'll call that 9B. And I'll solve for the height of that triangle. Turns out that the height of that triangle is 12. So I needed to find that. Actually, I needed to find that for 2 reasons. I'm going to need to find that for the perimeter of the triangle too. But just to find the area of that base, I needed that to serve as the height of that triangle. So the area of my base is 1/2 base times height, or 1/2 of 9 times 12, which is going to be 54. So I have that part. The height of the prism. This is a little bit confusing because we're dealing with 2 heights here. We're dealing with 2 bases here. This is all referencing the area of the triangle on the bottom, whereas this stuff is all talking about the 3-dimensional triangular prism. The height stretches from one base to the other. That's that 11.5. And the perimeter is, again, referencing the base. I'm just talking about adding up those 3 sides, so that would be 36. Now I'm ready to plug into that equation. The surface area is 2 times the base, which I found was 54, plus 11.5, which is my height, times the perimeter of that triangle, which is 36. So I multiply those together, I get 108 plus 414 gives me 522 inches squared as my final surface area of that triangular prism. So it's really just important that you keep the different parts straight. The 2 bases and the 2 heights are referencing basically the 2-dimensional and the 3-dimensional parts of that shape. All right, so here we're trying to find the volume of this trapezoidal prism. So we can see that we have a trapezoid base, and it's stretched by this height. That's creating this volume. Really, that's why this volume formula is so simple. It's the area of this trapezoid, and it's stretched by that height. The same way it's length times width times height for a rectangular prism, it is the exact same thing. It's the base being stretched into a 3rd dimension, creating this volume. So I'm looking at the area of that trapezoid first, which means I'm going to use 1/2 base 1 plus base 2 times the height. On your formula sheet, you see this written a little bit differently. 1/2 times the height times B1 plus B2. So this B1 and B2, it's really just talking about the top and the bottom of that trapezoid, and the height is talking about that straight up and down distance. So 1/2 times 20, the height, times 45 plus 60 as my 2 bases. So that's going to turn 10 times 105. So the area of the trapezoid is 1050. That is the area of the base. That's this capital B. And that gets multiplied by that height that gets Basically, it's just stretching to create that volume into that third dimension. We have that two-dimensional shape stretched into the third dimension, which is what's really creating that volume, times that 80 for the height. That gives us a final volume of 84,000 centimeters cubed. Last example, we are looking for the volume of this hexagonal prism. So I need to find the area of that base and then it's stretched by that height to create that volume. Area of the base times that. So I'm going to use that to find the area of that hexagon. 3 times radical 3 divided by 2 times the side squared. So you do the exponent first, get 16, and then multiply it times this expression to get 41.569. I'm just going to round that to 0.57. So that's the area of the base. That's going to get plugged in for big B there. 41.57 times the height of the entire prism, which happens to be on its side right now. That's 10. So the total volume is 415.7 centimeters cubed.